Alright, this is going to be for 3.8 homework. For questions 1 through 4, we're just taking these functions here and matching them with the graphs accordingly. So basically how we're going to do this is by finding the zeros. So the zeros for here are going to be 1, 2, and -2. So 1, 2, and -2. Is that it right there? So this right here is going to be A. I think so. And then for 3, this is going to be -1, 1, and positive, or -1, 1, -2. So this has 1, like that right there. This has -1 for that right there, -2 for that one right there, so this one's going to be B. Okay, so C and D have to go with 2 and 4 here, so we're going to check. So right here, if you have x plus 2 squared, that's going to have a 0 at -2, but it's going to only touch. So you can see here at -2, it crosses, and you can kind of see here, so at -2, the function comes up, only touches, goes back down, and then it crosses again at -1, and that is what the other 0 is right there. So yeah, this one's going to be C, this one has to be D right there, and that checks out because this one has an x-intercept at 1 that only touches because the degree is 2, and yeah. Okay, we're going to graph this function given here. So we're going to have excuse me, we're going to have zeros at x equals 2 and x equals -1. So x equals 2, x equals -1. The degree is 3, so I know that it has to go down on the left and up on the right. It's also being squared for this one, so it's only going to touch right there. And so it's going to only touch right there and go up, okay? And then it's going to go down right here. And then we're going to check values in between. So let's say I plug in 0 into the function. So if I plug in 0, this becomes -2 squared, which is going to become 4. If I plug in 0 here, that becomes 1. So then at x equals 0, it's going to be 4. If I plug in 1, I get 1 minus 2, which is going to be -1 squared. So that's going to be 1. 1 times by, if I plug in 1 here, that becomes 2. So it's going to be 2. So it's going to be 2 right there. Okay, so I know that it's probably going to look something like that right there. Okay. For 6, so we have x-intercepts at -1, at +1, and at +3. It's a 4-degree polynomial because we got 2 factors here and then 2 other factors here. So that's going to be degree 4, meaning here it's going to go up and up. Now at x equals -1, it's going to touch. So it's going to be having that sort of behavior right there. And then here, it's going to have to cross. It's going to have to go through and go up right there. And it's going to have to cross right here. So it's going to have to come down, bounce, it's going to have to come back down, cross, and then cross. Okay, but now if we plug in some values, so let's say I plug in 0. So if I plug in 0, this becomes 1 squared times by, if I plug in 0 here, that becomes -1. And if I plug in 0 there, it becomes -3. So that becomes 1 times -1 times by -3. Which just becomes 3, so right there. So we'll just say goes up like that. Okay, let's plug in 2 right here. So if I plug in 2, this is going to become 3 squared. And if I plug in 2 here, this becomes 1. If I plug in 2 here, this becomes -1. So that becomes 9 times 1 times -1, so it's going to become -9. So it's going to go down there. Okay, and there we go. Let's do this one here. So we're going to have zeros at 5 and at -2 and at +3. It's a third degree polynomial. The leading coefficient is positive, so I know it's going to have to come up right here. It's going to have to come up right here. No touching the x-axis, so it's just going to have to go up like that. So it's going to have to cross here, and it's going to have to cross there. So we're going to be crossing here, crossing here. Okay, now let's plug in, let's say 0. So if I plug in 0, I'm going to get 1/3 times by -5 times by 2 times by -3. So these right here, when I multiply, is just going to become -1. So -1 times by -5 times by 2, that's going to become 10. So we're going to have a point up there. So we'll say it goes up there. It's going to have to come down, cross right there. So let's say we plug in 4 now. We're going to plug in 4. So I have the 1/3. If I plug in 4 right here, 4 minus 5 is going to be -1. If I plug in 4 there, that's going to become 6. If I plug in 4 there, 4 minus 3 is going to be 1. So this is going to become 6 divided by -3, which is going to become -2. So -2, so we'll just say it right there. Okay. Here we're going to have x-intercepts at -4, at -8, and at +1. Okay. So it's a third degree polynomial, positive leading coefficient. So it's going to have to go down right here. We're going to go up right there. It's going to have to cross there, cross here. So let's plug in -6. So if I plug in -6, I have 1/12. -6 plus 4 is going to be -2. If I plug in -6 here, that's going to become 2. If I plug in -6 there, -6 minus 1 is -7. Man, I hope this is an okay number, but it doesn't look like it's going to be. So this is going to become -4 over 12 times by -7. -7 times by 4 is 28. So 28 over 12, which is going to be equal to 14 over 6, which is going to be equal to 7 over 3. And that's going to be 2 1/3. I'm going to use the calculator to make sure that's all right. So I'm plugging in -6. Okay, store as x. Okay, so then I'm going to get x plus 4. We're going to have x plus 8. And we're going to have x minus 1. And then we're going to divide that by 12. 2 1/3. So 2 1/3. So, wow, it really only goes like that right there. Okay, cool. Okay, let's plug in -1, I guess. So plugging in -1. So we have 1/12. If I plug in -1, I get 3, I get 7, and I get -2. So then this is going to become -14 times by 3. So that becomes... Wow. That doesn't sound right. But okay. 6 times 5. Okay, yeah. So -42 over 12. Okay, divide that by 12. So we're going to have -3.5. So at -1, it's going to be -3.5. So like down here. So I'll just say it goes something like that. Okay. I wouldn't say worry about these ones right here. I don't care about those ones. I don't think it's worth your time to do. If you do them, great. Just use Desmos, plug it into Desmos, find the x-intercepts, call it good, but I don't think it's worth your time. Okay, so for 11 and these ones right here, we're trying to see if the function is even, odd, or neither of those. So we're going to check and see. This is right here is checking to see if it's even, and this is going to be needed if we're going to see if it's odd, okay? So f of negative x, so I'm going to plug negative x in right here. So 4 negative x to the 7th is just going to be equal to negative 4 x to the 7th, because this is just going to change everything to be negative, because negative to an odd power is still negative. So equal to negative 4x to the 7th. And we can see from this that these are not equivalent, so it's not even. So it's not even. Now let's check and see if it's odd. So let's do negative f of x. That's going to be equal to, so multiply that by negative 1. So that's going to be negative 4x to the 7th. And these are equivalent. So since these are equivalent, then it is odd. All right. So let's plug in negative x here. So we get negative 2 negative x to the 6 plus negative x squared, which, because negative is being raised to an even power, that doesn't change the term. So it's still going to be negative 2 to the 6, and then that's still going to be plus x squared. So because these are the same thing right here, because f of negative x is equal to f of x, then it is an even function. Okay. All right. So continue the process. So negative x to the 4th plus 3 times by negative x squared minus 2. So that doesn't change, x to the 4th, still that, plus 3x squared, and that's still going to become negative 2. So this ends up being the same thing as it was before, so it is an even function. For 14. Okay, for this one right here, so we plug in negative x. So plugging in negative, I'm going to kind of be a little bit more quicker about it now. If I plug in negative x, that will end up changing that to be negative x to the 5th. That will change that one to be negative 3x to the 3rd, and that will change that to be positive x. So we know that these are not the same, so it is not even. And then so now we're going to see if it's odd by trying to see if these two are the same. So if I multiply everything by negative 1, that becomes negative x to the 5th minus 3x to the 3rd plus x. And now I compare these two, and they are the same, so this is odd. Okay. Going down here, so if I plug in negative x to an even degree term, that's going to keep it the same. Plugging in negative x to an odd degree term is going to flip it to be negative 5x, and obviously that's going to stay 1 because we can't plug in negative into something that doesn't have an x. And I can see that these are not the same, so it's not even. And then if I multiply this by negative 1, negative f of x is going to be negative x squared minus 5x minus 1. And if I compare these two, it's also not the same. And so because these are not the same, and because these two equations are not the same, it's not odd. And so it is neither even or odd. Okay. If I plug in negative x here, that's going to flip it to be positive because it's an odd term. That's going to change that to be negative 2x. And then we can see that these are not the same. Okay, and then if I multiply by negative, that's going to change that to x to the 3rd minus 2x plus 9. I can see that these two are not the same, so it's not even, it's not odd, so neither even or odd. So neither. Okay. Whoops, already have some of that done right there. Okay, for these ones right here, we're just collecting information. So what are the x-intercepts? So keeping in mind, so this right here is 2, and 3 would be like right here. So maybe the x-intercept is going to be at 2.5 comma 0. That's the only x-intercept there. The local minimum is right here. And so that's maybe that's at the point 1.5 comma, so the y value, this is 2, 3, 4, 5, 6. This would be 7 and 8. So it might be like, if this is -6, this is -7, somewhere between there. So like, I don't know, maybe -6.5. If you have a value in between 6 and 7, -6 and -7, I think that will be okay. So that's the local minimum. The local maximum is right here. So that's going to be, if that's -2, this is -4. So maybe it's at -3, comma, and the y value. So this is -1 and this is -2. So somewhere between -1 and -2. So maybe -1.5-ish about. Okay, so that's the local maximum. Okay, where is it increasing? So I can see two intervals where it's increasing. So it's going to be increasing here and increasing here. So it's going to be increasing from -infinity all the way to this x value, which we said was -3. And then it's also increasing from this x value, which we said was 1.5 to infinity. Okay, and then it's decreasing in between. So for decreasing, I would say decreasing from -3 to 1.5. All right, for this next one right here, so the x-intercepts are, we have 2 right there. So this is 1, 2, and 3. So the x-intercepts are going to be at 1, 0, and at 3, 0. The local minimum is right here, so at 2, -2. And then the local maximums, well, the local maximums are also going to be the x-intercepts, so 1, 0, and 3, 0. It's increasing. I see it's increasing here and here. So that's going to be from -infinity up until 1 right here. And then again, it's increasing from 2 to 3. And it's decreasing here, so between 1 and 2. So between 1 and 2, it's decreasing. And it's decreasing after 3. So we'll say 3 to infinity. Okay. For this one right here, so finding x-intercepts, so we're counting by 2 again. So 1, 2, 3, 4. So we're gonna say -4, 0, and then this will be. Oh wait, what the heck? 1, 2. No, we're just counting by 1. Sorry, just kidding. So that would be -2, 0, and then this would be -1. That's, or sorry, that's. This is 1 and that's 2. And so 1/2 might be there. So I don't know, maybe like 1.75. So 1.750 maybe. Okay. Local minimum, we only have one minimum. That's going to be right there. So like -1 point, I don't know, 2. -1.2, comma. So this would be 1, 2, 3, 4, 5. So -5, maybe. Wait a minute. That's not right. I'm looking at the wrong part right here. So -1.2. -1.2. I need to be talking about this. So this is 1, 2, 3, 4, 5. This would be 6. So this might be like, I don't know, -5.2, I guess you can say. So -5.2. So that would be the minimum. And the maximum, there is no maximum here. No local maximum or maximum just in general. This doesn't count as a maximum. This is actually referred to as a shelf because it increases and then it stops increasing, but then it just increases again. And so because it doesn't go from increasing to decreasing, it's not a maximum, so no maximum here. And as far as where the function is increasing, I see it's increasing from here and onward. So it's increasing from -1.2 to infinity, and it's decreasing from -infinity to negative 1.2. So negative infinity to negative 1.2. So for 20, some x-intercepts. So right here and right here. So negative 1, negative 2, negative 3. So like maybe negative 3.50. And then we have 1, 2, and 3. So I don't know. I know it's not really, but we'll say 2.50. Local maximum. Again, I don't think there is, or sorry, local minimum. Local minimum is right here. So that's going to be negative 1, negative 2, negative 3, negative 4. So maybe negative 3.75. Oh, that would be for the y, sorry. Negative 3.75. And then for the x value, that's going to be negative 1, negative 1.2. Okay. And then, yeah, so no maximum, because it's pretty much got the same exact shape as this one over here. Pretty much the same shape. And so no maximum. Increasing, so I can see that it's increasing from that point onward. So we're going to say that that's increasing from negative 1.2 to infinity, and decreasing negative infinity to negative 1.2. Okay. All right, and that should be everything for this homework.